So let's talk about two variable inequalities. All right, a linear inequality is an inequality in two variables whose graph is a region of the coordinate plane that is bounded by a line. Basically, with a linear inequality, you are drawing a line and then you are shading. Think of it like when you had a number line inequality. You solved just like you had an equation, but then your answer was not one x. It was a set of numbers. This is the same thing, except you're talking about two variables. So you're talking about a coordinate plane. Your answer will be some type of line, and then you'll shade above or below the line. So that whole group of the graph will be your answer instead of just the line itself. All right, so the first thing you do is you graph the line. They will give you some type of inequality. You can put it in slope-intercept form, which is really the easiest thing to do when you are graphing inequalities. So if you had just graphing a line, standard form, you can graph that way. You can just get your two intercepts and plop it in there. But when you're graphing inequalities, it's easier to put it in slope-intercept or y equals mx plus b, because it says y is larger than this or y is smaller than this, and that's how you know how to shade. So when you get your y by yourself, that actually tells you how to shade this. A couple things to point out. If it is just a greater than sign or just a less than sign, this guy will be dashed. Relate it back to when you had just a greater than or just a less than on a number line, you had an open circle that indicated it did not actually include that number. The dashed line does the same thing. If you have or equal to, then you will do a solid line, indicating that that line is also part of your answer. So dashed line is like the open circle, solid line is like the closed circle, right? Or equal to and just greater than less than, that's how you determine that. Once you graph your line, then you're gonna say, okay, where is my y value? My y value is here. This is greater than, just greater than, I dashed it, and I looked at my y value and I shaded everything greater than that on the y-axis. So that's why this part of the graph is shaded. This one, less than or equal to, they did a solid line. They found the y here, and then they shaded everything below it because the y was less than. And so they left this in standard form. I will tell you, you probably don't want to do that, because if you have a negative in front of your y, when you get it in slope-intercept form, it's going to flip that guy. And so if you have like minus 2y or even just minus y, and you don't get it in slope-intercept form, you may forget when you go to graph it that greater than less than would have flipped when you actually solve for y. And so you want to make sure if it's in standard form that you're paying attention to your positives and negatives there. I always get them in slope-intercept form, just as a teaching method to make you double check yourself and make sure you're shading the right part of the graph. The first example they gave us is in slope-intercept form. We're going to graph it just like we would normally graph a line. We're going to say, well, my y-intercept is at -3, so I'm going to go to -3 here. My slope is 1/2, so I go up 1 over 2. And now I'm going to determine what I'm going to do here. According to this, it is just less than. So when I do this, I am going to do a line here, but I'm going to make sure that I have a dashed line. So I'm going to dash this line as I draw it here. All right. And so you have a dashed line there. And the next thing I'm going to look at is I'm going to say, well, it is less than that line. So when I go to shade it, I am going to find my y and I'm going to shade less than that. So I'm going to shade everything below it. And that whole thing there would be my answer. When I grade these, I grade on, did you graph the line correctly? I grade your y-intercept and your slope. Then I look, did you dash it or make it solid correctly? And then where did you shade it? So it's like a 3-part thing that I'm looking at. Did you graph the line correctly? Did you make it dashed or solid correctly? Did you shade correctly? Example 2. At least 35 performers of the Big Tent Circus are in grand finale. Some pile into cars while other balance on bicycles. 7 performers are in each car. All right. 5 performers on each bicycle. Draw a graph showing all the possible combination of cars and bicycles that we could use in the finale. All right, so our variables here are the number of cars and the number of bicycles, right? And so if we're looking at this as a standard type equation, we're going to say, well, this many people can fit into a car, this many people can fit into a bicycle. And so the way they set it up with your X as your number of cars. And it doesn't matter. You could do it either way. You would just have to label it so that you know. Y is number of bicycles. And so if you do that, then make sure you note that on your graph. So they don't show it here, but I would want you to say, you know, number of cars here and number of bicycles. This will help you, especially if you have a habit of not using X and Y. Now, if you use X and Y, then you're naturally going to put X on the X-axis and Y on the Y-axis. But sometimes people put C for cars and B for bicycles, and then when they go to graph it, they don't remember where they put it. And so make sure that as you graph it, you note which side is which when you're doing something like this for a word problem. All right, if I'm going to create an equation, then I'm going to go back and I say, well, 7 can fit in each car, so that would be 7 times X. And then 5 can fit on each bicycle. So I'm going to say 5Y. And then at the very beginning of this problem, they told me how many performers I have altogether. That's 35. Now, this is a situation where I need to now figure out what I'm going to use as far as greater than less than. Because this line would represent exactly 35 people. But it said any combination of possible. It doesn't say with all of them full or the most that you can have. And so that means that 35 is the absolute most performers, right? I mean, is the minimum performance. At least 35 performers is what they just told me, at least. So if 35 is the minimum, I'm going to make this greater than or equal to, because it said the least number, at least 35. If it had said at most 35, I would have flipped that the other way, all right? Now, in this situation, I wouldn't necessarily put it in slope-intercept form. My Y is positive here, okay, which typically it will be with something like this. You could have where they're like, it's going down by a certain amount, so you would have a minus there. But so in this case, when it is a word problems are often easier to graph with intercepts. Now, be careful, again, and watch your Y, and we'll talk about that when we do our graphing and our shading. But it's easiest now to just say, where am I going to cross the Y-axis? Where am I going to cross the X-axis? And so I do that by just zeroing out the other guy. If I have no performers in the cars, how many performers would I have to have in the bikes? Well, I'm just going to zero out my cars and say 35 divided by 5. So my Y is going to be where? 7, right? I zeroed out my X. Yeah, I zeroed out my X. And so then, yes, if I zero out my bicycles, how many would have to be in the cars? That one's going to be 5, right? Yeah, so that would be my intercepts there. And then it wants me to, of course, graph it, all right? This is a greater than less than problem, and I want to graph it. Now, obviously with this, we don't have to go into the negatives because we don't have a negative number of cars or bicycles, all right? Now, if I were to shade this according to this particular one, am I going to shade above or below it? Above, because my Y here is greater than, and I do not have a negative in front of my Y, okay? If there was a negative in front of your Y, it would be below it, because when you divide that negative over, it would flip it, okay? Because I don't have one in front of my Y, I can just shade above it. Now, logistically, this would not go on forever, right? So even though this is a coordinate plane, we can't have an infinite number of people performing, right? I mean, that just doesn't make sense. But for the sake of this graph, that represents all your combination of performers. This line represents the bare minimum, all right? And so if you go below this line, you have not met the qualifications of at least 35 performers. And so anywhere on this line would represent 35 performers. Obviously, you can't be in between them, but anywhere where you cross it would necessarily be 35 performers. All right. All right, so let's look at the first one. It said, find the minimum number of bicycles if there are only 3 cars available. We're going to take the 3 cars up here. You hit it about there. So we're going to say 3 bicycles. 3 bicycles would have to be available, right? Minimum number, so 3 bicycles. And then it says find any possible combinations, not based on just the 3. So you could have picked any combination over here that you wanted to. All of those would have been viable combinations. Really, anything on the shaded area or anything on the line, since the line is included. The next question says, and we talked about this a little bit, give the domain and range for example 2. Domain and range are whole numbers. They're whole numbers because we're talking about the number of cars, the number of bicycles. So domain of this would not be like all real numbers. This would actually have to be whole numbers. You could have 0 cars. You couldn't have half a car, right? So whole numbers. And that is whole numbers for domain and range for both of those. And they are limited. So minimum number of cars would have been 5. That was our intercept. So anything 5 and up for cars in whole numbers, and anything 7 and up for bicycles in whole numbers. All right. So you can also have inequalities when it comes to absolute values. Remember, we have solved absolute value inequalities, right? You set up 2 inequalities. You flip the greater than less than, right? We did all of that. And so you can also graph them. You graph the actual absolute value graph, the V, exactly the way you did in the last section. You still apply the dashed or the solid lines based on whether it's or equal to. And then you shade according to your Y. Again, sometimes you'll be shading inside, sometimes you'll be shading outside. It all depends on where your Y is and which way it is pointing. All right, so let's look at this first one. Where's my vertex of this first one? Where's my vertex here? It's at, give me the coordinate point, the XY value. The 4, 5, right? So it's going to go 4, 5, right? Right 4, up 5. All right, what's my slope of this one? 1. So I am just going to have a normal 1 slope. It is pointing up because I can see that there. Now, based on what we talked about with the lines, is this going to be solid or dashed? Solid. So I'm going to do a solid line. And I'm going to do a solid line. All right. And then we're going to look at the shading of it. All right. The shading of it. So Y is less than. So I'm going to look at my Y value here. If my Y value is here, it's going to go down. If my Y value is here, so you can see where everything below your Y value, that's going to be down here. And so my shading is going to actually be down here. That would be my shading for this one. All right. Let's look at the next one. So the next one is not kind of in a form that I would leave it in to graph. I would actually change this before I graphed it. Get the Y by itself. And so before you even start to graph this guy, get the Y by itself. What's my first step to get my Y by itself here? Yeah, I'm going to subtract my 3 over. So I have negative Y is greater than absolute value of X plus 1 minus 3. What else do I need to do? Yeah, multiply or divide by negative 1. And that's every piece of it. This guy here and that guy here. So I have Y because, my crazy Y there, because I divided by negative 1, I need to flip this. So that's going to flip. I just have a negative in front of my absolute value. It doesn't go into it. Negative 3 and negative 1, that's positive 3. All right, and so now that I've done that, I am going to graph it. So I'm going to graph it based off of that right there. All right, so where's my vertex going to be for this one? Yeah, left 1, up 3. Is it pointing up or down? Down. And what is my slope? 1. Now, is this going to be solid or dashed? It's going to be dashed. So I'm going to dash my line here. And then I'm going to dash it on the other side. And then, is it greater than or less than now that I have actually solved for Y? It is less than. So I'm going to look at this particular one and I'm going to say, well, my Y value is here. So I'm actually going to be shading inside of this. I won't be shading all of this part, because every y value here, I need to go underneath it. So I'm actually going to shade below that, which will look like it's inside that v there. So if you look at this one, I just subtracted my 3 over and then divided everything by 2. So this was a 1, so that became 1/2. The 3 that I moved over became 3/2. My vertex is still going to be right 5 and down 1.5. And then this is my slope. Like, you have to look at it the same way. You could actually put that through there.
That's what I did.
If you had foiled it through, you would have had 1/2. Right, but remember, you have to put this over that guy. So you have to think about from your very first time, it's your x. When you have a slope inside here, when you're doing the shifting, you have to think about, go back to the negative b over m. You have to go back to the negative b over m if there's a slope inside here. So the shifting around and just using the h and the k or whatever they do when they call it, whatever, I think it's h and k that they talk about, only works if you have a 1 slope. So you really have to go back to your brain from what the first section and think about the m over b as well. Go back to your, if you put it through here, then you're going to have to do negative b over m for your x value. And if you had done that, you would have had 1/2 x minus 5/2, and you would have had 5/2 over 1/2, which would have been 5. Yeah, it still would have been 5. Does that make sense? So when I have it out here, I don't shift it through. And if you want to use that always, just factor it out, and then you can always use your shifting. So if it were to give you one that has like 3x plus 6 minus 3, you can take the 3 out if you want to. X plus 2. And then you can use your shifting around if you pull it out to the front. But if it's inside, you have to go back to negative b over m from our first. All right, writing them is fairly simple. This first one's a linear graph. And so you're literally just looking at slope, y-intercept, right? So we have y equals mx plus b. Y, my b here, well, that's where it crosses. That's going to be a negative 2. So y equals mx plus b. My b is negative 2. My slope, well, I'm going up 1, 2, 3, and over 1, according to what I can see here. So what do you think my slope's going to be?
3.
Yeah, it's just a 3. So y 3x minus 2. And then I'm shading below my y values. So this is going to be less than. I don't put an or equal to. How do I know that? Because it is dashed. If I look at the one on the right, what type of function is this going to be? Linear or absolute value?
Absolute value.
Absolute value. So now I just have to decide how it is shifted. All right, so it shifted right 3 and up 2. How would I write that? Right 3, that's what? Plus or minus 3? Minus 3. Close that. Up or down is what? Plus, yeah, 2. It is pointing up. All right, so I know I don't have a negative. My slope is up 1 over 1, so I don't have anything on the outside. And I shaded above it, so I'm going to do, I know greater than. Do I do equal to?
Yes.
Yes, because it is solid. All right, so recognize what type of function you have and write it. So go ahead and do those two really quickly, A and B. All right, so check your work. On the first one, absolute value equation, y is less than or equal to x plus 4 minus 3. The second one is a linear equation, y is greater than or equal to 2x plus 5. 2x plus 5.